Let's do one last example of acceleration, a little more difficult one. So hopefully you have your calculators ready to do this. The escape velocity of Earth is 40,200 kilometers per hour. Okay, what that means is if you are in a rocket or whatever and you are trying to get away from the Earth's gravity, you have to be going at least 40,200 kilometers per hour. Otherwise, Earth's gravity will pull you back in. Okay. So let's say that a rocket reached that speed after 2 minutes. What is the rocket's acceleration? And then we'll convert to kilometers per second later. Okay. So your formula is no different. Okay, acceleration equals final velocity minus initial velocity divided by time. Okay, so let's fill in our numbers. Acceleration equals my final velocity, 40,200, okay, kilometers per hour. Initial velocity, it was 0, it was resting on the launch pad. This is 0. And divided by the time. It took 2 minutes to do that. Okay, so it took 2 minutes there. So I divide that out, and I get 20,000 after I round, so 20,000. Now, what's my unit label? Okay, the velocity, that was measured in kilometers. It says kilometers per hour. Okay, what was my time measured in? It was in minutes. Okay, and then of course I need my direction, and let's just say up because it was going up. Okay, so can I circle this? All right, done. Is that a legitimate unit label, kilometers per hour per minute? Well, yes. Unless if I asked you for something different, that should make sense to you. Every minute, the rocket is getting 20,000 kilometers per hour faster. Okay, that's pretty quick, right? Every minute it's getting 20,000 kilometers per hour faster. Okay, let's change that a little differently. Let's do what it says here. Let's put that now into kilometers per second squared, just so we get a little fun kind of calculating things. So we look back at the original problem here, and we see that the escape velocity was 40,200 kilometers per hour. The hours here we need to get to seconds. All right, the kilometers was fine because it says I wanted in kilometers. We need to get the hours into seconds. So I had my number, 40,200, and I want to get it from hours into seconds. Do I want a bigger number or a smaller number? Okay, well, I want a smaller number, right? Because it's not going to be going very far in a second, all right, compared to an hour. So I'm going to divide by 60, and I get 670 kilometers per minute. Okay, so 670 kilometers per minute is the same as 40,200 kilometers per hour. But I'm in minutes, I need to get this to seconds. And again, I'm going to need to divide because in a second you're not going very far. So I divide by 60 again, and I get, after rounding, I get, it looks like 12 kilometers per second. Okay, so that's the escape velocity in kilometers per second. Kind of imagine that. To escape the Earth's gravity, you have to be traveling 12 kilometers per second. All right, pretty quick. So now let's just do my formula here. Acceleration, my final velocity 12 minus initial velocity of 0 divided by my time of, it's not 2 because 2 is in minutes, right? All right, 2 is in minutes. How many seconds is 2 minutes? Well, 2 times 60, okay, that would be 120. Okay. So my answer becomes 0.1 kilometer per second squared up. Okay, so 0.1 kilometer per second squared up. Okay, And if you wanted to convert that to meters per second squared, you certainly could. That one you can probably even do in your head. Just use your King Henry died money drinking chocolate milk conversion table thing, and you'll get about 100 meters per second squared. Okay, so every second it's getting 100 meters per second faster. That's pretty quick. Okay, last thing with acceleration that we're going to talk about is circular motion. So we see the windmill there, and its blades are turning at a constant speed. So are they accelerating? Okay, well, are they speeding up? No. Are they slowing down? No. Are they changing direction? Yes. Okay, they're constantly changing direction, so we call this circular motion or continuous acceleration. An object traveling in a circular motion is always changing its direction, therefore its velocity is always changing, so it is accelerating.